Today we're going to build a web dashboard for the Learning Tasmota PCB without any JavaScript or web programming. Let's get started. Welcome to episode 6 of marktroyer.tech. In episodes 4 and 5, we connected our Learning Tasmota PCB to a public MQTT broker and then installed an instance of Node-RED on the Heroku service. This week, we will use this infrastructure to build a web dashboard to monitor the sensors and switches while also building controls to actuate the buzzer and LEDs. All of this will be done without any web programming. Before we do this, let's take a moment to understand the function of Node-RED. In my own mind, I would describe it as a middleware layer that uses a visual paradigm. In Node-RED, functional nodes can be linked together to build logic flows to solve a given function. For example, I've installed around 8 outdoor lights around my house, ranging from spotlights to floodlights and also plugs for Christmas lights. All of these lights are controlled through devices running Tasmota. Some of these lights are on timers that are programmed to turn on or off based on the time of sunset. Here in the Netherlands, the sun currently sets at around 4:40 p.m. It will set at 10:30 p.m. in 6 months from now. I use Node-RED with a logic sequence that turns the lights on 30 minutes before the sunset and then turns them off at midnight. I never have to adjust the timers to the change of season. This can be easily set up with Node-RED. In addition to building middleware logic, Node-RED can also be used to build nice web dashboards. This is what I've done for our outdoor lights, and everyone in the family can control them through a local web page on their own smartphone. Today we will build a dashboard using Node-RED for our Learning Tasmota PCB. This will consist of 4 primary steps. First, we will extend the Node-RED functionality by adding a dashboard node library. Next, we will build a chart widget with real-time light readings. We will then build a switch sequence, and finally, as part of the bonus section, we will import a collection of sequences of a complete dashboard for the Learning Tasmota PCB. Let's head over to the computer and get started. I've just logged in to the Node-RED instance that we built in episode 5. As we can see, our simple 2-node sequence is still working as it is connected to the test.mosquito.org MQTT broker. As I mentioned, the baseline installation of Node-RED only includes around 45 default nodes from 3 different libraries. We will need to add some additional nodes to our palette that allow for the building of a web dashboard. In order to add more nodes to the default installation, we need to go to the Manage Palette menu option. We can see here that we have 5 node libraries that were installed. 3 of these came installed by default. There are currently over 3,000 contributed node libraries available in Node-RED. It's worth spending some time searching for what is available. For example, I was thinking recently about integrating some of my indoor IKEA lights into our family lighting dashboard. I wonder if there's a node palette library for IKEA lights. Let's search for IKEA. Yes, it appears that there are 3 libraries. Let's take a look at this one in more detail. Interesting. This is something for further study. Getting back on track, let's install a node library that we need to build the dashboard. I will simply search for the word dashboard. Here's the one we want, the second library in the list, the Node-RED-dashboard library. Let's take a look at the description of this node library quickly. To install this, we only have to click the Install button. As I have already installed this library, this is not necessary. But you get the idea, however, how easy it is to find new node functionality and add this to your Node-RED palette. Our environment is now ready. Before we get started, I would like to modify the debug sequence from the last episode. I would like to break this into 2 debug sequences. One that will show all the telemetry messages that are published and the other one for all the status messages. By being able to watch these incoming messages, we will be able to build our dashboard to our specific needs. So let's slightly modify the first debug sequence. Currently it is subscribed to all messages from our Learning Tasmota device. Let's modify this to narrow the subscription topic to only the telemetry messages. To do this, we simply need to replace the plus wildcard in the topic with the string tele, T-E-L-E. Let's also modify the debug node and simply call it tele messages. Now let's create a second sequence for all the status messages from the device. As opposed to dragging and dropping both of these node types to create a second sequence, we can simply select this existing telemetry sequence and then replicate it. We only have to modify both of these nodes with the status MQTT topic and then rename the debug node. We will modify the MQTT topic for this second sequence by replacing the string tele with stat. That's it. Let's also rename the debug node to status messages. With that complete, let's create our first dashboard control and begin with a chart for the light level. This will not only allow us to see the current light level, but also see previous light levels as they show in the chart. Before we do this, I will change the frequency of updates on our Tasmota device to every 5 seconds, as it is currently set to every 5 minutes. Let's go to the Tasmota console interface and run the command teleperiod5. Going back to node red, let's add in 2 nodes starting with an MQTT in node and a dashboard chart node. We will set the MQTT in node to subscribe to the telemetry sensors topic for the device. Conceptually, we will be routing all incoming sensor messages to the chart node. If we look at the debug output for the telemetry data, we can examine the payload. The first thing that we'll notice is that the payload data is sent in a JSON string and not an object. We will first need to add in a node that will transform the JSON string to an object. The JSON node does this. Let's look for the JSON node and add that in. There are actually no needed changes to this node. The JSON node will now output an object. The chart node expects a JSON object with a property called payload with a floating point or integer value. Currently, the JSON node outputs an object in the payload field with lots of information, including both the light level, the temperature, and some other information. We need to transform this so that it only outputs the light value, which is an integer in this case. To remap this change, we will use a change node. In this case, we will set the payload value to the value currently in the payload.analog.illuminance variable. Now we can pass this directly to the chart node. With that configured, let's edit the chart node and set up a label for the chart called light. We can now save this setting and press the deploy button. To see the dashboard, we go to the dashboard area and then click on this link, which will open up a new browser tab. I will also be adding in the live view of the Learning Tasmota PCB so that we can see what happens. This is the dashboard. If everything works, we should see new data coming in every 5 seconds or so. And it does seem to work. Let's now create an actuation control on the dashboard for the relay of the Learning Tasmota device, which is actually an LED. This will require 3 nodes, an MQTT in node, a dashboard switch node, and an MQTT out node. Let's add all 3 of these nodes onto the canvas and connect them together. We will start with the MQTT in and the MQTT out nodes. Next, let's add the dashboard switch node. For the MQTT in node, we will need to subscribe to the status updates to the Power 1 device. The idea being that we want the switch control to be updated with all changes to the status of the device. We will therefore subscribe to the topic stat/device_name/power. On the MQTT out node, we will want to forward all of the changes in the switch to the command topic cmnd command/device_name/power1. This creates a full loop for updates no matter how the switch is actuated. It could be through a button on the device, indirectly through a Tasmota rule, or some other instance of the dashboard. Finally, we need to configure the switch. The first configuration change we will need to make is to untick or disable the pass-through message feature. We will then need to configure the switch icon to show the state of the input selection. In this case, this will be the output of the status subscription. In other words, we will only change the web control status when we get a status confirmation on the Power One state. Finally, we will change the switch payload output to be a string of either on or off. Now let's deploy the sequence and head back over to the Dashboard tab. We can see that the dashboard has been updated with the switch control above the light chart. Let's toggle the button a few times and verify if the green light on the Learning Tasmota PCB also lights up. That seems to work as expected. Now let's press the momentary push button several times on the physical PCB and verify that the web control also changes state. That also seems to work as expected. So we have just successfully configured two dashboard control. It's now time for the bonus section. I will show you how to import a complete dashboard for the Learning Tasmota PCB. Before we do this, the question must be asked, how do we save the configuration we just created for later use, or perhaps for importation in another Node-RED instance? The best way to do this is to use the Export Node feature. To save or export our nodes, we can select the nodes that we want. I will select all of these nodes by simply dragging a box around them. I could have also used the Control-A feature to select all of the nodes. We then use the Export selection under the hamburger-like menu. A dialog box will pop up. From here, we can see that a condensed JSON representation of all of the nodes appears. We can either save these to a file or copy them and paste them to some other place for good keeping. We will save these for now and then download them. A file called flows.json has been created that we can save for later reference. Let's just take a quick look at this in Notepad. Previously, we talked about creating a dashboard for the Learning Tasmota PCB that manages all of the sensors, buttons, LEDs, and buzzer. We will now import a previously created JSON file with a complete dashboard for all of these elements. I will start off by deleting all of the nodes of our current configuration and deploy this empty configuration. Looking at the dashboard, we can see that it is now, in fact, empty. Let's now import a JSON file with the target configuration. We can see that it is a properly formatted JSON file with many elements. Let's click Import. We now see all of these newly added nodes. Some of them are familiar. Let's look at a wider view to see all of them on the canvas at once. And finally, let's click Deploy. Let's look at the end result, which is the dashboard, and test it out. To begin, we can see data already flowing into the two charts for the light and the temperature. If I place my hand over the Learning Tasmota PCB, we will see things get darker and warmer. Let me also put my finger directly on the temperature sensor for a moment. You'll also notice some new buttons to clear the stored data in the charts. Let's clear the light data. It will start to repopulate with sensor values almost immediately. Now let's test out the other buttons. First, let's begin with the LEDs. We've already tested the LED 1 relay, so let's focus on LEDs 2 and 3. We can toggle these through the web control and they seem to work as expected. As you may recall, the second momentary push button is linked to LED 3 through a Tasmota rule, but it is configured to work directly as an actual push button. In other words, pressing the button down will trigger the LED on, but releasing it will turn it off. The same goes for the web control. Let's try and see if the web control reacts as expected. Indeed it does. LED4 is a PWM or pulse width modulation configured LED, which means in normal terms that it's a dimmer. By sliding this bar, we can control the intensity of the LED light. Let me move the web slider control back and forth a few times and see what happens. And finally, we have a buzzer button. Pressing it triggers the buzzer to go off 5 times with 100 millisecond delays. And that also seems to work. So everything is working. I will let you go back and review the entire node flow on your own. The JSON file is in the notes below. I would encourage you to test and experiment with variations of this dashboard configuration and study the MQTT topics used for both subscriptions and for publishing. Also pay attention to some of the if-then logic in the simple node sequences. It's now time to wrap up. Today we built a simple web dashboard that allows us to monitor and actuate the Learning Tasmota PCB. This is done through the test.mosquito.org MQTT broker. As you can see, Node-RED makes for a great middleware environment for implementing logic through visual programming. It is also ideal for implementing web dashboards. It is a lot lighter weight than typical home automation platforms such as OpenHAB or Home Assistant. For basic needs, it may be all that you need for some simple automations. Before I leave, I would like to reference once again the Learning Tasmota PCB, which you can have manufactured by PCBWay. The URL for this design is in the notes below. I would appreciate it if you could vote for this design and concept. It will help me expand the growth of this channel. If you found this video useful or interesting, please click the like button. Please also consider subscribing to this channel to get a front seat when I release new videos. This is Mark at marktroyer.tech signing off.